Welcome to a TIS production. I'm Mark and I'm going to run you through the PV checks on some solar arrays. I've got a couple of examples which we're going to go out to site and do some testing on. But before we do that, there are some key things we need to know and some things we need to put into our instruments to ensure that what we are measuring is accurate. So I get a lot of questions on my social media channels around testing of solar arrays using the PV checks and IsoTest. And I thought we would cover all of that off in this little video. Some of the common mistakes people make are the input data they're setting with their solar panels within the instrument, also the lead arrangements, and some of the other critical bits of information you're going to need when you are carrying out these tests. So before we jump out to site, the first thing you are going to need to have is the data sheet of the solar panels you are testing. Now I'll pop a little screen grab of this data sheet here because it won't come across super duper clear to you guys through the course of this video. However, the key points that you need is the electrical data. So these are your standard test conditions values. So in this particular example here for the 435 watt Trina panels, we have got our VOC at 51.8 volts, which is quite high voltage. And we've also got our VMPP of 43.6. So they're the two bits we need to enter in our solar panel data box if you was using this particular set of panels. And then we've got our ISC of 10.64 amps and also the IMP of 9.99. Now, one of the other key bits of information you need is the temperature ratings. And it took me a while to figure out what these actually are, but if you look down there, you can see we've got the temperature coefficient for Pmax, VOC and ISC. So Pmax is the gamma, VOC is the beta, and ISC is the alpha. So you're going to need those bits of information, and a critical point of note is notice the negative sign before some of those values. So you do need to set minus and positive. It is a bit of a chew using the instrument to input that information. It doesn't shoot up and down the values fast enough for my liking. However, it can be done, and we only really use 3 or 4 different panel sets. So it was quite a quick process for us to get all of our panels into the instrument. You can use the software though. There is the app that you can use on your laptop and put all of your solar panels in there ready and waiting to be used. And equally you can download data afterwards as well for review should you wish. So that's the data sheet. The other bit is familiarising yourself with the components. So we've got the PV checks itself. We'll have a closer look at that in just a second because there is some key settings in there. But we've also got our SolarO2 and the irradiance meter. So you need to familiarise yourself with those and how they link together. So you can see there's a physical cable between these two things. In essence, this is kind of a remote data logger. So it goes with the irradiance meter up onto your array, collects information at a set point in time, and then transmits that back to your PV checks at a later point. So it's important that you sync those together. We'll show you that happening in the video as well. And then there's also the clamp meter. So this is for your efficiency test primarily, and it needs to go into the right port on the test instrument, and you need to set the right scale. So in most cases you're going to be on the 10 amp scale. If you tell the instrument that's what you're using, and before you clamp it around any cables, don't forget to press the 0 in button, otherwise you could impact the values you are measuring. So we'll have a little look at the PV check. So if we turn it on, and it has an array of settings, and as I said, we're going to delve into it out on site, so there will be some voiced over segments of this coming as well. But if we go into the menu segment, the archive modules bit is the one I really wanted to focus in on. So you can see all of those settings in there, and that's where we input the information from the data sheets. So we must make sure that we're doing that. And also in the settings area itself, you can, for your remote unit, so the pyronometer, however we're going to call it, you can set that to be in the efficiency test or in your IVCK test. So if you've got them set to yes, it's going to look for that remote connection rather than using the physical wire, because you can just plug your irradiance meter direct into your test instrument. So if you're up close to the array, you can do away with the SolarO2 for your efficiency test and plug it straight into the meter. And one of the jobs we've got to show you later on in this little video, we can do that. The array is right next to our SIG Energy inverter outside. It's within arm's reach for a tall fella like Matthew, and we're able to do that. But on my install, that's not possible. The array is on the top of the house and we need that remote function to data log the irradiance value and then send that information back to the test instrument. So there's some subtle differences there, and these are the settings you need to adjust for, you know, the mode of operation, if you like, for if it's using a remote monitoring or a hardwired monitoring. And otherwise, most of the functions in here are pretty straightforward. So your IVCK is basically a multifunction test of your strings. It's going to do an earth bond measurement to your array frame, it's going to do an IR value through the strings, and then it is going to do a VOC and ISC calculation. So you need to tell it in the selection settings how many modules are in your string. So you can see up there it's set to 9, and that's the Trina 415, so that was the last test I was doing. And then you can set your insulation resistance value as well. Now, the reason we went to my house to do the IVCK test is Matthew has optimizers on his roof. And optimizers don't like the IVCK test. They play havoc with it. They cause trouble with the ISC values. So if you have got optimizers, this is a test you're probably not going to be able to do. And equally, there's a potential of megaing those optimizers that you could damage them as well. And that's the difficulty we have when we're trying to verify our installation. Now, optimizers come with a lot of the safety functions built in that the instrument can confirm. So it's looking for regular insulation resistance measurements. They're doing arc detection. So they can look for any of that in your array cabling and panels as well. Temperature, there's all kinds of checks they're doing, and if they detect any of that, they shut down. However, the efficiency test is something that you can do at a point in time while you're with your array and verify that it was performing exactly as it should be. And with things like potential induced degradation and your capacitive induction and all of those things as well, having that data the day you commission a system is super valuable. If you return to that job again, if the customer's doubting the generation of their array and they think they might have PID causing a problem, you can take your instrument, go and do an efficiency test, compare that data. The test set will actually tell you in itself, as you'll see later on in this video, if that is a reliable value or not. Without further ado, let's go off out to site and run through a couple of testing examples of how we set our leads up and how we go about doing our IVCK test and the efficiency test. So first up is making sure your instrument is correctly set up. You can use the irradiance meter direct into the PV checks, and if you're doing that, there's some key bits of data you need to pop into the instrument just so it knows what it's working with. Otherwise, those measurements will not be accurate, so make sure you pop in those into there. And then coming back to the panels, as you can see, depending on your panel of choice, all of these values are adjustable, and you can do that in the instrument or you can do it in the software. Whichever method you use, make sure they are accurate, because again, for your performance measurements, those will not come out as true unless you get this data right. And you can see the screenshot there of this particular panel set, so we can make sure they are all referenced into the instrument as needed. Now, when you are doing your IVCK test, you need a bond back to earth, you need your pos and neg, you need the irradiance meter, and you need that blue lead clamped onto the array frame. That's so that the data that is measured can be recorded as accurate. So your leads must go into the right terminals. You then go into the meter to try and record a result. Now with Matthew panels, we can't do that because he has got optimizers. Very awkward of him. But if we jump off to my solar panel array, you can see I've got Trina 415s, and we are able to do that test because there is no optimizers. So there's 9 panels in this string. And again, we're using the Solar O2 up on the array with this one because it's a bit further away than at Matthew's house. So we can set that up for the watts per meter. You can see that being read in the instrument. If we hit test, it will run through the checks. It's going to do the earth bond test. It's going to do our insulation resistance test. And it is also going to check our VOC and ISC are correct based on the panel type. And you can see there we've got an OK result off the array. We can save that in the instrument for review later and also in the software. It's really easy. I often do that because you can print it out and pop it into your handover pack. And again, once you've got the hang of this and you've got your leads all right, it is an absolute doddle. So now we've got all of the panel information loaded in, we can go into the efficiency test. With that, we need our wireless transmitter, which Matthew has got just over there. I'll show you that in a sec. He's just fired it up. But we need to set our array size as well. So this is 2.25 kilowatts in total. We've also got our clamp meter. You need to remember to zero this. So that's zeroed off and around the positive on the inverter. This is with your system running. So with our DC isolator open and some probes that are going to keep us safe while we're doing this test, we've also got the Solar 2, which is currently off, and we have got our PV checks. So if I get this now back to the efficiency test, and if Matthew can turn on the Solar 2, it will start to connect into here. You can see we've now got the RF connection. So if you stay where you are, and we can see that it's measuring irradiance off the roof at 85 watts per lumen meters. I've got my probes the wrong way around, so if I put my probes into the DC isolator, doing that carefully, and we've now got voltage, we've now got current, and we have got that measurement up on the roof. So we can hit start. Now it's waiting for the start of recording. The Solar 2 should go to a hold state. Okay, so we can see we've got hold on that instrument, so it's saying hold for 29 seconds, so we need to wait for that sync up with the instrument. That's just where they're getting themselves time synced, I guess, so that it knows the data being transmitted off the array. We're very local to the array on this one, however, most properties you're going to have to shoot up the scaffold with the Solar 2, go and pop it next to your array, and then come back to your instrument to start proceeding with the rest of the test, or use a helper. But in our case, we can just stand next to here now and just wait for it to do its thing. So we can now see it's running, the recording. Now it's up to you how long you leave that. I'm just going to leave it going a couple of seconds or so, just for the purpose of this video. So if we now stop that test, and it will try and download that information off the Solar 2. Again, you'd have to go and get it off the roof and bring it back for it to do this, but we're very close. And we can see here we have got the data that we've recorded there. So it's measured all of this off your array, it knows what the panels are, it knows what the string output should be, and it's giving us an outcome that this is a pass. So we know that our array is within tolerance based on the temperature we've got, and all of the rest of the information that we've inputted. We can save that information for later, so I'm just going to save that as 2, and then you can review it in the software. So I hope that video has helped answer some of the questions of the setup we need with these instruments to obtain values whilst we are out on site. I've had those frustrations myself when I've been there unable to get values out of the instrument because it's telling me that the voltage measured is too high, the current's too high, the data's unacceptable in its result, and every single time that traced back to me setting the tester up incorrectly. The instrument itself is doing its job. It's saying the voltage is too high because it is. You maybe only put 2 modules in the string when really there's 5. The current could be too high because there's optimizers there, or you may have bifacial panels that are pumping out beyond the rating of the instrument. It could be that you're in that time of year where the panels peak beyond their standard test conditions as well. That's something to consider. I know some of the DMEGs have 14 amps of current in them under standard test conditions. However, if you're in sort of early April or early October, and there is a lot of sunshine but a cooler temperature, those currents can peak beyond that value. So it's something to keep in mind. And the team at TIS will do their very best to help you. I know they will because they are absolute superstars. However, it's really difficult when you're not out on site and there is so much to get wrong to solve that problem. So all I would say to the installers out there is practice this. It took me a while to get used to the kind of data entry that's needed, the setup of the probes and the leads. But once I'd gone through that, testing of these arrays now is really easy. It takes minutes. It's a good peace of mind for us to know that things are both safe and performing correctly. And you know, without that effort, you're forever going to be on the phone trying to get an answer to something that is usually your fault. That's the brutal reality of it. And I've got the t-shirt on that. So yeah, keep going, practice where you can. If the instrument's not playing ball and it's saying there's something wrong, delve into it, get to the bottom of it, put that work in. If I can help, I will. On my social media accounts, drop a DM over. And like I say, the team at TIS will do their very best for you. And yeah, the results speak for themselves once you get to the bottom of what this setup is. We've seen in the course of this video, we've verified a system is performing as it should be. We've got that evidence now, we've got that data. It can produce a certificate for the handover packs, and also be used for referencing back to later if we're going to look at things such as PID or any other problems that may develop through the course of time. And the safety side of things as well. So if you've got a normal string array and there's no optimizers on there, you want to be absolutely certain that your cabling is spot on, that your insulation resistance values have been done correctly alongside the performance. And these instruments have it all built in. Before we end the video, I want to mention there is some new products from TIS now. This is the PV Checks. There is the Pro or Plus version that's out now. I think that basically combines the IsoTest and this into one product, and it will test higher currents as well for your IVCK tests. I think it's up to 40 amps. I'm sure the guys at TIS will be able to correct us on that if I am wrong. And the same with the Solar O2. There is now a Solar O3, which is a newer variation on this with your irradiance meter and the remote transmitter that goes off to the array. I'm not lucky enough to have one of those yet, but it is next on our list of purchases. So when I do get my hands on one, I'll make another video along the lines of this showing how it works. One of the key differences, I believe, is the Pro can do bifacial panels, whereas the Checks cannot as well. So there is some subtle differences in there. And it also has the fault finding functions of the IsoTest built into it. If you've got any questions alongside this video, do drop them into the comments. I know the team at TIS will look out for them and respond accordingly. And yeah, I hope that has been some help. Otherwise, I'll see you on the next one. So this is the system we're going to do the testing on for TIS with the videos we're making. We've got the PV Checks over here and some tools and bits and pieces. So we're going to set to doing that. Got the cables running up. They go across up here and then onto the array on the roof. There's only 5 panels here. It's all in hand's reach, so it's going to be absolutely ideal for this little video. And we just could do with a bit of sunshine for the minute. Yeah, it's getting through. It's getting through. Meet Susie. Hey, Susie. And Otis. He's a bit more flighty. Hey, Suze. Hey, Otis. Hello. Are we friends? You smell Bruno and Cooper. Hello. So one of the things you need to do with your PV Checks is to input your data of the panels. It's quite a long-winded process on the instrument, so I'll just give you a real quick look at it. But if we go to New, you can name your panel, and then you need to start running through basically the information on the data sheet. Now the one that always catches a lot of people out is these gamma, beta and alpha values. So alpha is your temperature coefficient, which is often referenced IOC. Your beta is the temperature coefficient for voltage, so VOC, and your gamma is the coefficient for Pmax. So alpha, beta and gamma translate into those on your temperature ratings. That confused me for a while, so I'm going to slowly input this data into here and I'll show you when I have done it. And that's then entered in. It's basically all the data off this data sheet and mixed in with your coefficients and your tolerances. So that's all in there now, ready for the IVCK and efficiency tests. So you need that information in there. So we've got all the gear and no idea. We've got the clamp up onto the array, super handy that Matthew's 6'6", and even I can reach that, I reckon. We've got our irradiance meter up there, so we're just on with recording the efficiency test. Around this way, we've got the inverter, so we've got our earth clamp on to the inverter there, and yeah, you can see Matthew's done a cracking job taping up his lug there. It's a good job this is his house. So yeah, we've got the strings out into our test instrument. Excuse the noise, someone's trimming their bush. So yeah, we're just running through that, and this is all going to have to be voiced over for TIS because the noise here is ridiculous. So as I said, your IVCK test doesn't like optimizers, and you have got to be really careful with that. So I've jumped back to my house with an array that doesn't have optimizers. These ones are Trina 415s. We've got 9 of them in the string. You can see we're measuring voltage and irradiance. I've got the Solar O2 up on the array. I've also got the earth bond set up as described earlier on in this video. And if we hit test, you can see now it will start to measure. So this is checking the insulation resistance through your panels and your strings. It's also checking the bonding of your array and its performance in terms of VOC and IOC. And you can see it has given us 3 OKs, which is what we need. and our outcome is okay, so we know that that string is performing correctly and safely. So now we've got all of the panel information loaded in, we can go into the efficiency test. With that we need our wireless transmitter, which Matthew has got just over there. I'll show you that in a sec, he's just fired it up. But we need to set our array size as well, so this is 2.25 kilowatts in total. We've also got our clamp meter, you need to remember to zero this. So that's zeroed off and around the positive on the inverter. This is with your system running. So with our DC isolator open and some probes that are going to keep us safe while we're doing this test, we've also got the Solar 2, which is currently off, and we have got our PV checks. So if I get this now back to the efficiency test, and if Matthew can turn on the Solar 2, it will start to connect into here. You can see we've now got the RF connection, so if you stay where you are, and we can see that it's measuring iridians off the roof at 85 watts per lumen meters. I've got my probes the wrong way around, so if I put my probes into the DC isolator, doing that carefully, and we've now got voltage, we've now got current, and we have got that measurement up on the roof, so we can hit start. Now it's waiting for the start of recording. The Solar 2 should go to a hold state. Okay, so we can see we've got hold on that instrument, so it's saying hold for 29 seconds, so we need to wait for that sync up with the instrument. That's just where they're getting themselves time synced, I guess, so that it knows the data being transmitted off the array. We're very local to the array on this one, however most properties you're going to have to shoot up the scaffold with the Solar 2, go and pop it next to your array, and then come back to your instrument to start proceeding with the rest of the test, or use a helper. But in our case we can just stand next to here now and just wait for it to do its thing. So we can now see it's running the recording. Now it's up to you how long you leave that. I'm just going to leave it going a couple of seconds or so, just for the purpose of this video. So if we now stop that test, and it will try and download that information off the Solar 2. Again, you'd have to go and get it off the roof and bring it back for it to do this, but we're very close, and we can see here we have got the data that we've recorded there. So it's measured all of this off your array, it knows what the panels are, it knows what the string output should be, and it's giving us an outcome that this is a pass. So we know that our array is within tolerance based on the temperature we've got, and all of the rest of the information that we've inputted. We can save that information for later, so I'm just going to save that as 2, and then you can review it in the software.